Good morning, everyone. My name is Ricardo Brunello. I'm Vice President of Telit, in charge of our industrial solutions business. It's a pleasure to have all you guys here for this webinar. As you might know already, Telit is a very strong player in the industrial IoT, and our core product for industrial solutions is DeviceWISE. DeviceWISE is an industrial IoT platform that is helping customers all around the world to have a better productivity out of their production lines. DeviceWISE, as an industrial IoT platform, is also a very OPC friendly platform. And in sometimes we can replace the necessity completely of OPC using our native drivers, but also we have all our OPC interfaces ready to intercommunicate with any device and any IT system. It's a pleasure for me to introduce here Mr. Gerhard Lapp. Gerhard Lapp is our senior engineer, and he's going to demonstrate how DeviceWISE can help industrial companies to overcome the OPC challenges in the shop floor. Gerhard, please go ahead.
Yeah, good morning, ladies and gentlemen. It's an honor for me to have the opportunity to present this. The goal of this presentation is to create an awareness of what it means to collecting data in our today's hyper-connected world, and not only collecting data, but distributing, managing, and transforming data required, allowing us to connect to individual components, different systems, and many times at the same time. This page is asking the question, where or how do we get the data in terms of what's available? We all are aware of the big picture, and this is completely regardless whether you are in a manufacturing environment, you are in an outfield environment, in the nature, wherever you collect data, you have to deal with big analog data. Machines who are automating processes, they specifically using PID controllers to control and automate and convert the analog world into a digital world. And as a consequence, when we talk about collecting data, they include many different data categories, including, for example, sensor measuring vibrations, pressure and flow, cameras performing thermal scanning and pattern matching, motors sending precise waveforms to execute and control algorithms. In other words, in a world of smarter hyper-connected devices, machines, infrastructures, and environments, the data itself is a key. And as we all know at this point, collecting data, many times we face a challenge that we literally don't know which data to collect in order to get the answer we are looking for, whether you're looking for performance improvements, business improvements, cost reductions. So when it comes to automation and integration of data from all different kinds of sources, we have to research in many cases what type of data we are collecting. And not only that, once we get to the point where we collect data, many times we collect many more data, which at the end we no longer need. So it seems like we integrate a temporary solution first to find out which data are giving us the results. And then we have to deal, in addition, not only collecting the data, but we have to deal with all the different technologies available. Whether it's a network technology, whether it's Bluetooth, Z-Wave, Zigbee, Wi-Fi, there's numerous solutions available how you can collect data. And in reference to OPC, OPC is just one method allowing to collect data from field devices or devices itself. As we all know, in the early 90s, Purdue actually university designed and created this famous triangle, structuring a manufacturing process into field devices, control devices, stations, work centers, and enterprise levels. In other words, it separated the process automation layer with the production automation layer and the enterprise layer to manage productions. and the connections allowed us to create islands of automation. In other words, we connected robots, machines, PLCs to HMI and SCADA systems, which then allowed us to control and supervise individual assembly lines versus MES systems, which allowed us to connect to HMI and SCADA systems and, of course, field devices as well. In order to manage and run the production. However, the structure and the hierarchy was still very static. We connected one component with another component, and were in many cases providing different standards, different communication layers between those applications. And one of the methods we used was OPC. I think many of you remember OPC was a need to standardize the interface to the field devices, and that was done in the early 90s when the PC took place and Windows came out, and at that time Microsoft, Rockwell, Siemens, and others did actually a great job in order to create OPC, which since then has been a standard in this industry. So just to mention that we are not competing against OPC, we are complementing OPC where needed or where required. The same with HMI and SCADA systems. We are not competing with HMI and SCADA system. We complement HMI and SCADA system. And this is part of the presentation to show you the difference, what it means, an application enabler being used as, for example, an HMI and SCADA system to visualize, to control and supervise a production line or a process, versus an application enabler, which DeviceWISE is, to allow you to write applications to connect third-party components. In other words, our strength and our focus is to be part of an interconnected world in order to create smart systems, smart products, smart factories, allowing you to connect the components, many times concurrent components, among your factory. So the triangle was actually changed and replaced by Gartner in 2017. It is no longer a dedicated production layer or process layer or a manufacturing execution layer. The layers are now separated on all levels of manufacturing into device layer, of course, communication layers, because we have numerous ways to communicate the device information, into information layers, because in order to do predictive maintenance or analytics, you need to have an information layer. And this is actually the challenging part. Many times you do not know which data to choose to provide you the best information for your needs. And therefore, you have to have the capability and the flexibility to collect data and change the collection of data, and to try different approaches in order and run different algorithms in order to get the information you need. Then, of course, there is a function layer, which consists of streaming processing, event processing, dispatching, and orchestration. And then machine learning is slowly but surely arriving at our end. And then, of course, a process layer. And this is exactly our focus. In order to have the ability to connect data which are being produced on those different layers, you can use OPC as one method, but it will not complement, it will not be able to perform all the interfaces. You, in the current system or the current HMI or SCADA systems you have available, you would have to add packages or do all kind of custom programming in order to accommodate all those different interfaces required to connect the layers. And this is actually our focus in our product, that data collection itself is not the only thing you need to master. When you collect data, you also need to manage the data. You also need to have the capability to distribute the data. And then, of course, not one single component or system where you exchange data with is compatible. So you need to have the ability to transform data. And this is part of the presentation where I'm going through those individual steps to hopefully create the awareness what you actually need to have a system which allows you to connect individual components. So just to repeat again or to reiterate, DeviceWISE is a software agent and a software agent only, which runs on multiple hardware platforms as a software agent, allowing you to connect third-party components and applications. Whether it's a device to a database, whether it's a database from one end to another, or whether it's from device to device, or whether it's from ERP systems to databases, through the cloud or without the cloud, it has all the transport features, all the connectors available that by simply writing connectors or configuring the connectors between those components, it's a single standalone software agent which runs on numerous platforms. So in order to connect and collect this information, DeviceWISE, as I mentioned before, we have a couple categories where you can run as an asset gateway or an enterprise gateway. And you connect device access layers, of course, to any PLC, robots, DCS, and sensors. And the key about this interface is that we develop and write our own drivers. We don't use OPC to do this, and one of our tasks and dedication is that we keep the same as OPC is adding device drivers to their library. We are adding device drivers to our library, with the difference that you don't need to install an additional software package like the OPC server. You don't need to install an OPC client as part of maybe an HMI package. You don't need to have a tag database so that the client knows which tags to read, as an example, and then write the logic to do the interface. This is an all-in-one solution. You can connect from a single node to as many different systems you like. This is all an integrated part of DeviceWISE when accessing device access layers, including sensors or whatever is available on this layer. And then in reference to the upstream, and this is based on the long history of DeviceWISE, which was originally designed by IBM. So this is not like a software which came out of two smart guys developing a solution in the garage. But this was actually based on a white paper which was developed in conjunction with IBM and Mercedes a while ago, pretty much at the same time when OPC came out. And the premise or the goal of this software was simply based on the fact that we want to be able in a manufacturing networking infrastructure to access data without having a special skill how to access this data, but makes the data within a network transparent and immediately accessible. In other words, DeviceWISE not only can connect components from south to north, meaning from device access layers to enterprise access layers, but it also can connect from east to west, meaning you can seamlessly connect Siemens with Rockwell PLCs, for example, or Torque tools, and vice versa, while you also concurrently can connect SAP with Azure, IBM WebSphere, SAP HANA or DB2, because it doesn't, to DeviceWISE, it doesn't make a difference. You will see this when I show you at the end some small live examples, that as soon you connect to whatever component you connect to, the data immediately become available and you can process them and build your business logic to it. Also very important, when you collect data from different systems, you need to be platform agnostic. Today, to run on Windows or Linux is not enough. You have to be able to run on different hardware platforms like routers, gateways. We support, for example, running on Cisco routers. Imagine in your plant, you're already using Cisco routers or Dell routers. So you could install DeviceWISE on that router and you would have instant access to all your network components connected to this router anyway at this point. Meaning you could eliminate an entire PC gateway layer just designed and established for OPC servers. However, because we talk about components and we want to stay compatible, there's no doubt that OPC is a standard. And when we look at the transition of OPC now from DA to UA, we see that the goal is, and which is a very smart goal, that machines now become OPC compliant in a way that UA allows you to assign methods to, it's like calling subroutines, calling functions, downloading programs, the alert management is incorporated. This is very good, but you have to realize, again, it's designed for the machine layer. It's designed for the device layer. It's not designed for large or different types of data collection. And so let's go to the different varieties we face when we collect data in real time. And what is really required to effectively collect data? The number one thing is that we have to live with an existing world. Not every machine has an Ethernet interface. Not every machine has OPC interface, UA or not UA. Not every machine is connected to any kind of network, so you would need to use IOs to connect to the machine to get the information you are interested in. Look at the old generations of injection molding machines, and here we see a trend that Euromap is becoming a standard for injection molding machines, but it's not OPC, it's a different type of protocol. So in order to effectively collect data, you must be committed to develop and continue improving the device drivers. That's the same effort OPC has. But in addition to the different types of data collection, you have to have the ability to do string or binary-based data collections regardless of tags or variables. For example, when you read from a Rockwell PLC or a Siemens PLC entire data blocks, because you really don't know the individual interpretation of the variables structured in the data block. For analytics guys, they are really not interested in the speed of a certain motor, but what they are interested is in patterns for identifying and interpreting memory patterns. So we stream, in some instances, entire data block regions up to their analytical software so they can identify over a period of time, 1 month, 2 months, 3 months, certain patterns which they then match to certain events which occur. So it's a completely different aspect how you actually interpret and analyze memories. In this instance, you need to be able to do bulk and array-based data collection. Of course, unsolicited message support is very critical, so you don't have to poll the data when the PLC is programmed in such a way to change information only or to send the information only by when it's changing. So you send unsolicited message support. And wherever we can and wherever the protocol allows this to happen, we natively build unsolicited message support, whether it's a talk tool, whether the PLC supports this. So in other words, we always try when we natively use the protocol required between device and DeviceWISE, and we develop the interface to maximize the functionality of the protocol available to us. Audio-video streaming capabilities is very important. Many times, if you look at laser cutting machines, wouldn't it be nice if headquarters, the developers and process developers at headquarters can concurrently look at a video stream while they hear the audio while cutting the steel, for example. Things like this. So you have to have a certain capability to do those. Another example, many of laser cutting machines, for example, they don't support an Ethernet interface, but they have or can act as FTP clients. AC systems, other machine tools, they allow you to interface through FTP, although this is an old kind of standard. But again, we have to have the ability to deal with an existing world, and therefore we need to support the old standards as well, what we do. So in this case, we, DeviceWISE, acts as an FTP server, and then the machine itself can use FTP to send their files to us, which then, based on events, we can process and forward to the target where we need to have it. and then shared drive technology with, of course, Microsoft's technology in this case. And this is just a small list of different types of collecting data, not to mention the technology required to go over air, cell communication, Wi-Fi. So it's just there's an unlimited amount basically on how you can collect the data. So in other words, data collection should not be limited to available device features, but extend to end user requirements like streaming, mapping, packaging, etc. So it is more than just OPC collecting and managing individual tag databases, or in reference to UA, optimize the access to a machine so that you can actually start and download programs. But in this context, again, DeviceWISE has a capability to act as an OPC server, which means if in your suite or OPC world you don't have an interface to an existing machine, we could, for example, use or implement an FTP interface if required. But to the upside world, we can act as an OPC server, which would allow your OPC clients to connect to us as an OPC server, which then we translate to an FTP interface. And this is the strength of DeviceWISE, that we can switch among those technologies. On the other side, we also can run as an OPC client. If we don't have a native driver, but you have already an OPC server installed, why not take advantage of it? So in this case, we would act as an OPC client to connect to that OPC server, allowing us to get this information you are looking for. The next requirement is you have to have the ability to manage the data you collect. And why is this needed? When you connect two different systems with two different behaviors, the system you're trying to send data to may be off the network, may be disconnected, may be in a maintenance mode, may not be able to receive data, whether it's a database, whether it's an ERP system, whether it's SAP M2, whatever it is. So you need to have the capability to store and forward the data until the connection is back. So in all of our connectivity interfaces, we provide a store and forward feature so that if a connectivity is not available, we allow you to store locally the data, and of course that is limited to the physical memory or hard drive available to you. And then when the connection comes back, you have a configuration screen which allows you to decide which data are being forwarded and being updated in your target system. The other reason why you need to manage data, in our effort to make PLCs smarter to download, in other words, the PLC is getting to a point where the PLC says, I'm out of an order, I need new orders, and requesting to download a new order because just to request additional work. Why does it have to be done manually? The PLCs are very smart, very intelligent, and they have enough memory now that they can process orders automatically, ideally. From an Industry 4.0, that's kind of what's required to turn an automation system into a smart automation system, that the machines start actually fulfilling or requesting material or requesting orders. So in this case, no matter what the reason is, the PLC is sending to you a request, but the ERP systems have a much different response time. It may take an hour, it may take a day before this response comes back. So now you have to have the capability to remember the request, store the related data, and when the response comes, you have to have the ability to map the incoming response with the outstanding response to send back to your PLC. And for that purpose, you have to have the capabilities that collecting data by itself is not enough. You need to be able to manage the data and to remember requests from PLCs to slower responding ERP systems. So to standardize the data among different systems, the end user should not have to be concerned about different data types and data presentations among two systems. The data presentation remains transparent regardless of its origin. Then the third pillar of collecting and managing data, and that's a very critical one. We call this actually data logistics. We allow you to connect to hundreds or thousands of PLCs based on the power your DeviceWISE is running on. At the same time, we collect the same node to connect to hundreds of databases if you need to, or different systems. You can connect to a historian database. You can connect to the cloud. You can connect to Azure. You can connect to Mongo or non-SQL based databases, to SAP systems. But as we know, just as a simple example, if we collect data from PLCs in a very high frequency and we stream those data and we want to store those data in the database, I think we all experience that databases by nature then is kind of a bottleneck. How do we overcome this? And for that, when we look at our transport interfaces or database interfaces, we have something which is called connection pool sizes. So we take advantage of the database's ability to handle hundreds or thousands of concurrent requests. But if the system is not designed feeding the database to deal with this kind of thing, you will always run into bottlenecks. And DeviceWISE is designed to allow you to define and create connection pools. It's like very similar when you go to your downtown at rush hour during normal day or during normal hours. Maybe one or two lanes are open going into the town. You have the ability in the evening during rush hours, they open up the lanes and suddenly you have 3, 4, 5 lanes into one direction just to compensate for the peaks and the burst streams. And that's exactly what we do with databases. So we take advantage of the database capability to stream and send and use concurrent connections so that the database itself can deal with the load and not being backlogged to our end so that we have to start backing up the data. And the other thing is, when it comes to data logistics, you can use DeviceWISE as an application level failover scenario. In other words, you have two DeviceWISE nodes connected to a single database from different PLCs and vice versa. As an example, you can configure DeviceWISE as a listener to your concurrent node. So your concurrent node is providing the interface functionality and the business logic, but the concurrent DeviceWISE node has the ability to listen to your main DeviceWISE node, let's call it. So, and if it recognizes that, for example, the PLC connectivity on one interface is not working, it could literally take over this communication and switch over to itself to provide failover scenarios. So in other words, you have alternative pathways how you can run and route your data to your targets. And last but not least, there is not a single system when you connect two systems where the data are compatible. So a system like DeviceWISE has to have, when you collect data, has to have the capability to transform the data from PLC strings, PLC integers, floating points are not compatible with REST APIs, with SAP interfaces, with web services. They need to be converted either into string and JSON format or XML-based formats, and vice versa. In other words, you receive an XML data stream or JSON-based data stream, which then you need to convert to PLC data. And that is functionality which is absolutely required. So combining those four features, collecting, transforming, managing, and distributing data is a fundamental requirement if you want to create a data concentrator within your infrastructure to allow you to access any data from anywhere in your network and collect those data and store it to your systems or target systems you want to enable. Besides transforming data based on the data types and characters of the data, there are different ways how you can or need to transform the data when you use methods like you could email data, for example, or you can use MQTT to publish this data. You can use UDP or TCP, and every type of stream many times requires a different type of format. That's why we support string and binary data. In many cases, what we do is we convert all the data into a binary data bucket, regardless of the size. And then we send binary data to our destination, where we convert this information to the system to the system, the ERP systems or whatever requires this. So long story short, as I mentioned before, DeviceWISE allows you, the key to DeviceWISE is that it runs on many different platforms, that it runs on many different, supports different operating systems. It supports all the Linux derivation, whether it's Red Hat, SUSE, or other Linux distributions, so that you can install the different nodes anywhere in your network, and wherever you connect DeviceWISE to, it becomes immediately transparent, those data. So you do not need to know the detail of, for example, if you convert a tag name to a PLC compatible variable, it's always a challenge. And agreed, it's automated now in many cases. But what we do when we connect to a device, whether it's a robot, a PLC, a torque tool, we gather and collect instantly all the available variables. That means we don't distinguish among a different set of variables. Let's get them all. Why not? And then let's decide which one of those variables we use. And that makes integration of data much easier. And then the most important thing about this is that now where you create or have a way to standardize and access your data, no matter where they are located, you can actually now focus on your application regardless of what the application is, which is integration and automation. In other words, you can connect PLCs with robots if you have to. You can connect SAP with Oracle if you have to. You can connect with existing HMI and SCADA systems. We have all the plugins right now for Microsoft, IBM Watson, SAP HANA, MindSphere, Azure, AWS. So there is no limit in what we can connect to, and our dedication is that we keep developing interfaces to the outside world. And then, of course, when you focus on the application, you can visualize, and that is because DeviceWISE is also able, where you can use, for example, Angular, and you write your own Angular-based web application. So DeviceWISE has a capability to run as a web server, run as an FTP server, an HTTP server or client, allowing you to connect to the nodes and look directly using your own web applications and using the web API of DeviceWISE to visualize your process. And here are just simply some samples of what customers have done to connect to their systems. And this is all open standard. As you know, writing a web interface has become really kind of a standard. And the access to all the DeviceWISE nodes, wherever you run it, is done through a web API in this case. So you can actually visualize your application or your data if you need to or if you like to. In this context, I like to show you some real examples about DeviceWISE switching to, some of you may know it, Workbench. So as I said before, the DeviceWISE is a software agent, and let me show you that what this really means. It's if you go to if you install it on your Windows node, for example, and then it's a service under Windows. So, and here is your core. This is what DeviceWISE consists of, and it has all the features which I just explained, allowing you to connect devices, connect databases, connect enterprise systems on each node or from each node. And then when you install those nodes on individual systems, you see exactly what you see here is a workbench. And this workbench is just a user interface. This allows you to configure the DeviceWISE individual DeviceWISE nodes by selecting a node. In this case, it's a local host running locally. Or if you want to go to a different node, this is a server running on 10.200. So by selecting those individual nodes, you have directly access, no matter where you are located, to your devices. And then I just show you, when you look at the device map, you see here all the different device packages. And it really doesn't matter. On the same node, you can connect as many devices as you like. Based on the performance of the PC, of course, or based on the performance if you're running on small asset gateways, on routers, for example, or modem gateways, then, of course, the number of connected devices is limited. But in this case, if you run on a high-end PC, for example, you can connect to e-sensors, you can create MQTT connections, we cover all the Mitsubishi, we cover all the Modbus, Modicon, Omron, Peer-link. Peer-link is the features which allow you to listen to other DeviceWISE nodes, so you can identify whether or not PLCs are connected, as an example. It also allows you to access remotely the PLC. So in other words, if you are on a different network in your assembly line, you can use Peer-link to connect to that DeviceWISE node to have direct remote access to that PLC. Then, of course, we cover all of Rockwell, Siemens, for example. So overall, we have over 1,500 different drivers, all native. And in addition to that, we support TCP, UDP, and of course, FTP, for example. And when you define those devices, let me just go to an example. Here is a control logics. And one of the features, it allows you to just enter an IP address, you enter your port number, you enter your CPU slot in which the CPU and the PLC is hooked up to, and then you have some tags which you can select. But one of the most important ones is you can actually create, based on the Rockwell functionality available, JSON files, which then you can use to very easily convert your entire tree structure of an Allen Bradley PLC into JSON to send this to, let's say, SAP or some other web service. Once the PLC is connected and started, you have immediate access to all the variables available on that PLC. We don't distinguish. You don't need to define a tag database. This is directly connected to the PLC, where you can easily read and write instantly this variable. And then when you provide the logic to read this angle to send to a database, then you just reference this logic, which is very simple to do. So in other words, let's just create a new project, or we can use an existing one in this case. I apologize. So I apologize. I just had a a hiccup with the workbench. So let's create a new project. And then we start this project. And then we create a new trigger. And then one important thing about DeviceWISE is designed to deal with events. In other words, whether you watch variable groups, different types of data, or if you can watch individual data. In our case, if we want to look at the PLC and look at the angle, we can say anytime this value changes or goes exceed, this logic will be started. So it's an all-in-one logic based on the device interfaces. And now we have the ability to collect this value and then of course the debug features. So to start this, so if we go back to the device and change this value, we should see a success here, meaning the trigger has executed. So I wrote directly to the PLC, and if I refresh this information, I see that this was updated, the trigger was executed, and now I could actually simply go ahead and create a transport interface. And you see here all the different interfaces to the ERP systems which are built in, whether it's an HTTP interface to web services, or if you or MES systems like IFS and ITAC, for example, then JMS, MSLQ. We support 100% every SAP interface. You can create a TCP interface. Watson, in our case, if we go to database, we see here that we support, right now I have installed DB2, DB2 400, Oracle, MS SQL, HANA, and regardless of the database, one important criteria about DeviceWISE is simply the fact that you see that the configuration doesn't change. It's all the same. This is what I mean when I say as soon you enter the data, they come into DeviceWISE, it becomes transparent. You don't need to know specifics about your target system, the database, Oracle, MS SQL, and so on. We do the work for you. You just define the interface. And in this case, I have a local interface. So to my local host, to an MS SQL server. And then all I can do or need to do is where the transport defines actually the interface to your enterprise system, I can use define which data and what I want to send to the database itself by using. And then you see here that it automatically browses all available tables. And now I have the capability to insert, batch insert, update, select, or run stored procedures in this case. And what I would need to do is just simply map the database columns, which are automatically browsed, to DeviceWISE columns. And when I save this, the information becomes immediately available in our trigger by adding a transaction. So now I select the transport map, and I select the transport map I created. You see here the columns which automatically arrive, and then I can go ahead and insert this information, like the current timestamp if I don't get it from the PLC, and any other information I have. And then I could instantly store the PLC information based on the event, because we said we want to store the change of the PLC variable up here, and we get this delivered to the trigger as an event variable data. So whenever the angle changes, we could actually create an insert into the database. The other option is when you look at devices where, for example, Siemens, many times what we do in this case when it comes to data collection, we have here an SS7 1500 connected, and you see again the configuration is the same. To us it doesn't really make a difference, or to the user. You just simply program an IP, the port address, and then you name your registers, and then you can collect. In this case we have two data blocks, a data block of 1, and then you can immediately access this information. And the key is that if you have a data block, let's say of 8K, you can read the entire data block as a functionality. In other words, don't even worry about individual tags if you don't have to. Just read the entire data block, which then you send up to your systems. So collect data, transform data, manage data, and distribute data is a key fundamental requirement if you want to have the ability to connect any system with any system available to you or you want to connect to. So it's an application enabler where you can write business logic to connect your systems and components regardless of the location or your environment.
All right, well that wraps up our webinar for today, everyone. It looks like we have a couple of questions here. So if you're interested in receiving the presentation, you can email me, kipley.simmons@telit.com, and I'm happy to send that out to you. We also have another question here that says someone's working with Yaskawa robots, and they asked, is there a library for this or just using Modbus protocol to do that?
The Modbus would be a package. So in other words, if you go to administration and then you see here the individual packages, all the packages are available to you and can be downloaded from our portal. And based on the version you are using, our sprint to improve and develop DeviceWISE is on a 14-day cycle. So every 14 days we issue new packages, new software features, and then based on your software release level, you see here, in your case, you would just simply download your Modbus package to install. And I think I have it here. So you can use a Modbus package to connect to your Modbus devices. In addition, if you, for example, go to our staging browser, you see here a Modbus interface. You can actually define your own XML-based device based on Modbus. So if we look at this, so again, rather than defining individual variable tags, you can see that we created a template for a Tyco C serial using Modbus. And you see here all the variables available to us. And then you can define input and output registers, the offset, where it is in the Modbus database memory location, and use this as a device definition, because when you create those XMLs in this Modbus directory and you look at the device definition itself, it suddenly becomes available as a device. And you see it down here, for example, in Integra C series power.
Alrighty, and it looks like that there aren't any more questions. So if you have any more questions, please feel free to reach out to us. Again, my email's right there, kipley.simmons@talk.com. We also have free trial versions of our licenses. So again, if you're interested, please feel free to contact me. We really appreciate your time today. Thank you so much, everyone.